Hi guys, what's up? In this tutorial, we are going to find the reaction at the support uh, through the hinge at C. So first, we need to find the uh, we need to draw the force of AY. Okay, and here we have AX. Okay. Uh, and we have AX. AY. Okay. So how many unknowns reaction do we have? We have four. One, two, three, four. So four unknowns reaction. And we have three equation. Okay, summation of moment, summation of Fy, summation of f of x that we can solve in order to find these four unknowns. But we have one hinge that makes me to break the structure into two parts. Okay. I will assume this is part 1, this is part 2. Okay, so let's start with the first. But we need to start with the least number of unknowns. Least number of unknowns is we have here two. Oh, sorry, guys. One, two, three, four. This is roller. We don't have here AY, okay? And we don't have here AX. We only have here AY. So what is the least number of unknowns? It's one. No, here we have here one, two, three, and we have here one. So we'll start with this. So this part will start. Then we'll start with the second part. Okay. So we have here support A. Okay, which is AY. Okay, and you have here F. There's a force of 40 kilonewton, and there is a 15 kilonewton per meter. Okay, and we have here B, we have C. C, it has to support CY and CX. Okay, so in order we need to find the moment AC in order to find these values. Summation of moment AC is equal to 0. Clockwise, take it as positive. Okay, we will find AY. Okay, but we need also to do 15 kilonewton. Look, if you need to just let's finish with AY. So AY clockwise, AY 6 plus 10, 6 plus 4, which is 10, uh, uh, plus 40 clockwise. Okay, since it's going like this. Okay, just expand the force. If you need, just expand the force, then go through it with C. It will be 40 times the distance of 2 meter, which is over here. So 2 meter. Okay, and we have a counterclockwise minus 15 kilonewton per meter equal to 0. Now you can either see it by side view, by looking at top. You will find it that is circular counterclockwise, or you either just just draw a line and then draw a circle line over here, and then draw a circle. As it goes like a clock, it is clockwise. Opposite to the clock, it is counterclockwise. So this is counterclockwise. This is clockwise. It's going the direction of the clock. This is going the direction of the this is going opposite to the direction of the clock. Okay, but you need the most important. You need to draw a curve on the tip, curve, and then see the direction. Okay, so AY will be equal to 49 by 2 minus 15, 65 over 10, which is AY will be result as negative 6.5 kilonewton minus 15. Okay, guys. So we need to change its direction. So it will be downward equal to 6.5 kilonewton. And we can from here we can find the this is roller guys. Okay. From here we can find Cy by applying easily by applying summation of f of y equal to 0. Upward is positive, so Cy is upward minus 6.5 and equal to 0. That's it. So Cy is equal to 6.5 kilonewton. So Cy is equal to 6.5 kilonewton. Okay. So from here we can get Cx. No, Cx is 0 because there's no any no, it's not 0. There is a force, there is an external force, so you can see summation of f of x plus equal to 0. Therefore, to the right side Cx, okay, to the right side is 40 is equal to 0. So Cx equal to negative 40 kilonewton. So let's change our assumption, okay. Our assumption will be inward, okay. So it will be 40 kilo, just move this thing, kilonewton, nothing, newton, okay. 40 kilonewton, okay. This is Cx. So let's go with the other beam. Other beams like this. Therefore 2 is uniformly 2 times by 8 plus 4, which is 12. 2 times 12 will be equal to 24. So 24 will be middle, 24. 24, okay. And you have here 2 times 12 is equal to 24. So since it is a rectangle, then it will be 6 meter, okay, at C. From C it will be 6 meter, okay. Here's 6 meter, and here also is 6 meter. Okay, and we have here right now we have 4 meter. So we are left with, okay, no, I can see that. Okay. Here's 6 meter. So here's 4 meter. 4 meter. Here's 2 meter. Okay, so 2 meter, and we have a roller at D, which is represent dy. Okay, and we have EY and EX, and we have an external counterclockwise. Don't forget this one, guys. So, and you have opposite of Cx is to the right. Cx 40 kilonewton. Opposite of Cy upwards is downward, which is downward is Cy, which is 6.5 kilonewton. So we need to find the summation of moment at E. Okay, summation of moment at E, which is equal to 0, clockwise is positive. Okay, this is my assumption. Clockwise is positive. Guys, don't forget this 30 kilonewton dot meter. Okay, this is counterclockwise, so we need to add it minus 30. We will not add those two since those two forces pass through E and Cx. We will this not include. We will not include it. So we finish with 30. Right now 24. So minus 24 time by distance of perpendicular, which is 6 meter, and we have dy, which is upward clockwise, plus dy clockwise. We have 6 plus 2, which is 8. Okay, which is 8. Then we are left with 6 cy, which is counterclockwise. Okay, so it's moving like this. Okay, minus cy, which is 6.5 time by equal to 0, time by the perpendicular distance, which is 8 plus 4, which is 12. Okay, so we can find it. The dy is minus 30 minus 24 times by 6 minus 6.5 times by 12, which is dy is 252 divided by 8, which is 31. So dy is 31.5 kilonewton. 31.5 kilonewton. Okay, so we need to find right now cx actually it is 40 kilonewton, because you can do summation of f of x plus equal to 0. So minus ex plus 40, which is equal to 0. Therefore ex will be equal to, this will be shifted to the right, then it will be equal to 40 kilonewton. Okay, so our assumption is right, 40 kilonewton. Or we can suddenly say that since the direction of cx is to the right, therefore it's opposed with the direction at ex, which represent as 40 kilonewton. So we need to find right now ey. We're left with ey. So ey, we can do it here, summation at f of y equal to 0, upward force is positive, so ey is upward. Okay, minus 6.5 plus 31.5 minus 24. Okay, so we have 1 2 3 4 2 3 4 equal to 0. Therefore ey is equal to minus 6.5 plus 31.5 minus 24, which is equal to minus 1 kilonewton. Oh, we need to change it actually. Ey is equal to 1 kilonewton downward. Okay, so ey it will be equal to, first of all, try to change it and say, okay, downward 1 kilonewton. Okay, this is e. Okay, so that's it, guys. We found ey is 1 kilonewton, and ex, which is 40 kilonewton, dy, which is 31.5, and ay. Right now we can write it as 6.5 kilonewton, of course, and dy is 31.5 kilonewton, and ey is downward actually, so we need to read this and write it downward, which is 1 kilonewton, and ex is 40 kilonewton. Okay,